Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle. And it's called Convicted Red Droplets by Nicholas Duhale. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. Digits along red parity lines must alternate between odd and even. So for example, if this were odd here, this would have to be an even number in these two cells here, which would force an odd number here, because you alternate between odd and even digits on a red parity line. And we also have, within cages, digits must not repeat, and they sum to the small number in the top left corner. So, for example, you could have something like, say, 2, 6, 3, and 7. That would be valid, because the digits do not repeat in this cage, and they add up to 18. 3 and 6 add up to 9, 2 and 7 add up to 9, both of which added up together adds up to 18. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, couple of things. Since we have an odd and even digit each, along a parity line, so every two cells along a parity line will have an odd and an even digit. Which means we have 4 sets of odd and even digits in row 3 and row 4, which means the remaining digits are odd, because there are 5 odd digits total in the digits 1 through 9, and 4 even digits. And in columns 6 and 7, those are odd, and columns 3 and 4, those are odd. What else do we have? We have in box 4, odd, even pair, odd, even, so this must be an odd, even pair. This is an odd, even pair, odd, even pair. Oh, we have the same thing here. These are 2 odds, right? Because we have odd, even, odd, 4 sets of odd evens here. So because of this, we have an odd, even pair here. We have odd, even, odd, even, odd, even, odd, even, and this must be odd. Same thing here. This is odd and even as a pair. This is odd and even as a pair. Okay. We have 2 of each here. We have 2 of each here, and we have 2 of each here, and 2 of each there. Okay. 12. To add up to 12, it's either going to be 1, 2, 4, 5, or 1, 2, 3, 6. Those are the only sets of 4 unique digits adding up to 12. So, that means we have a guaranteed 1 and 2 here, and a guaranteed 1 or 2 here. 1 and 2 here, sorry, I should say. Which means in the rest of rows 3 and 4, we cannot have another 1 and 2, right? Both of the 1s and 2s in rows 3 and 4 are taken up, 1 in this set of 12, adding up to 12, and this cage adding up to 12. So this cannot contain 1 or 2. That means the minimum has to be 3, 4, 5, and 6, which is guaranteed to be 3, 4, 5, and 6, because that's the minimum, and that adds up to exactly 18, which is what this sum has to add up to. So, remaining digits, then. These are both odd digits, so 8 cannot be there. Therefore, there must be an 8 somewhere here, and then an 8 somewhere here. Because again, these digits are from 1, 2, 3, 1, 2, 3, and 6, and 1, 2, 4, and 5. Well, we have a 1, 2, 3, 6, 1, 2, 4, 5 quadruplet, or sextuplet in row 3 and row 4. So this must be 7, 8, or 9 as a combination. This is 7, 9, 7, 9. We have a guaranteed 8 here. We have a guaranteed 8 here. 8 and 9 is too large because 18 does not... We have 8 and 9 plus 1 and 2 at minimum adds up to 20. So this has to be 7 and 8 here, which makes this a 1-2 pair, adding up to 18. 7, 8 eliminates 7 and 8 in the rest of the row, so no 7 here. It's 9, which means no 9 here. It's 7. So this becomes 8 and 9 as a pair. Well, in columns 6 and 7, we have also the digits 12, adding up to 12 here. That means we're guaranteed a 1 and a 2 here to add up to 12. It's, again, 1, 2, 3, 6, or 1, 2, 4, 5, adding up to 12, which means the remaining digits in this columns, 6 and 7, cannot contain 1 or 2, because we have a 1 or 2 here, and 1 of 1 or 2 is here, and 1 or 2 here, which means 1 of 1 or 2 is here. So this cannot contain 1 or 2. That means it's at minimum 3 and 4 here. And 3 and 4 plus at minimum 8 and 9 is 24. So this must be the minimum here. So we have to have 3 and 4 here as a pair. Again, there's no 1 and 2 here remaining. No, there's no 8 remaining here either. Remaining digits here cannot have 1, 2, so it could be no 1. So it's 3, 5, 7, 9 supposedly there. No 1 or 2 here, so we have no 3, 4, 5, 7, or 9. 6, 7, 9, I should say. There's no 8 here because we have a guaranteed 8 here and a guaranteed 8 there. What else do we have? 14. 4 digits adding up to 14 cannot contain a 9. Because 1, 2, 3, and 9 adds up to, at minimum, 15. So we could have a 9 either here or it's there. And we could have a 9 either here or there. With this set here, you cannot have both 1 and 2s be here, obviously. But if we tried to have both 1 and 2s be here in the 12, that means you would have to have both 1 and 2s be here, which would eliminate that possibility for the 18. This can't be 1 or 2. We have 3 through 9 here. Obviously, no 9 there. So because of that, whichever 1 or 2 is here, so we'll make those orange and green. This 1 or 2 cannot be here, so it must be here. It also cannot be, this green cannot be here, so green has to be there. Which means this can't be green, this must be orange 1 or 2. This must be orange 1 or 2. And we have to have green 1 or 2 here, and this must be green 1 or 2 there. Okay. So this can't be 1 or 2 either. So this is 3 through 9. However, we could have a 1 or 2 be here. That is possible. This could be... Okay, so green 1 or 2 cannot be here. Because to add up to 28, you have to be at least 4, 7, 8, and 9. So this is 4 through 9 as a possibility. No 7 here because of 7 in the box. So where is the green 1 or 2 in box 5? Can't be here because we're guaranteed 1 or 2 here. Both 1 and 2 here and both 1 and 2 here. And can't be here. Can't be both here because of the way that works. So this must be guaranteed green 1, 2 here. That eliminates green 1, 2 here. So green 1, 2 has to be here. Orange is one of those two. Can you have both of them? You could potentially have both 1, 2s here. That is potentially possible. Hmm. Hmm. Orange here. Orange can be any of these. Oh, 1 and 2 have to be opposite. Sorry, meaning they cannot be. Sorry, they have to. They are opposite parities, so they cannot be next to each other on a parity line. Sorry, they have to be next to each other on a parity line. They cannot be opposite each other. So this cannot be the orange 1, 2, which means this is a 1, 2, 1, 2 pair, which eliminates 1 and 2 in the rest of the column. So this can't be 1 or 2, which means where the orange 1 or 2 could be any of those 3. We don't know which. Okay. So it could be any of those. Um, um, these are the same parity. These are the same parity. Hmm. Uh, this is orange. This is green. 3 and 4 means this can't be 3 or 4 in the rest of the row. 28. What do you add up to? This is obviously an orange parity. This is green parity. That's not very helpful. Let's remove that. Let's just use orange and green for the numbers. No 4 here. So orange and green, 1 and 2 have to be in this set, in this row for row 1. We don't know where though. Orange and green cannot be. It's one of these guaranteed. It's that one guaranteed. So it has to be. Oh, that's not true. Green could actually be here. Hmm. We do know that this is correct though. Can't be here. It's one of these two. Oof. Okay. So it still does have to be one of those two, but we don't know. It cannot be here then, which means this is 1 or 2. Obviously, this can't be the other 1 or 2. This can't be the other 1 or 2. So this must be the orange 1 or 2 here. Which means orange could be one of those 3. We're guaranteed one of these has to be 1 or 2. Because to add up to 14, it would be too small. It would be 3, 4, 5, 6, 7. It could be both of them, right? Um, sorry. The sum would be too large for this cage. The cage sum would be too small, I should say. Um, again, there's no 4 here. Um, hmm. Remaining digits in. So these have to be 3, 5. This can't be 3, 5. This can't be 1 or 2. It's 3, 5, 7, 9. This can't be 1 or 2. So 3, 4, 5, 6, 7, 8, 9 there. These are 1, 3, 5, 7, 9 as possibilities. So, what do these add up to? These are seem pretty large. 22 plus 28 plus 24. 22 and 28 add up to 50. Is that right? Twenty-two plus 28 adds 28 adds up to 50 plus 24 is 74. Two sets of the digits 1 through 9 add up to 90. 90 minus 74 is 16. This has to be 3 adding up. This is at minimum 3 and 4. So 74, that would be 10. So this must add up to 10 here at minimum, or at maximum. This could be 5, 6 here. Hmm. Um, 74 plus 10 is 10. Or 74 plus 10. Oh, wait. No, it's 74 plus 10 at minimum. That's 84. Which means at maximum, this has to be. This has to add up to 6. 90 minus 84 is 6. So that means this has to. If this is 3, it can't be 3 and 3 in the same row. So if this is 3, this is 1. If this is 5, this is 1. So 1 cannot be either of these digits, which means we have a guaranteed 1 here. Again, this is 3 or 5 here. So that means I think this adds up to either. It's going to be either 3, 4, 3, 6, or 4, 5. It can never be 5, 6 here. So we know 1's here, which means these 4 digits do not add up to. Do not have a 1 with them. Which means we know 1 has to be one of these 2 digits. Can we do something similar here? "24 is kind of big, and so is 18. This restriction was very, it was very restrictive there. Um, um, So this is 3. This must add up to 9 there. Does that help us any? Not really. Um, remaining digits in row 5. We have 1, 2, 5, 6, 7, 8, 9. Obviously no 7 here because of 7 in the box. No 9 here because of 9 in the column. Um, hmm. Do we have any restrictions here? I'm not sure. Probably not. 18 plus 12 is 30. 30 plus 24 is 54. What? And this is at most 16, obviously. Yeah, it's not that restrictive. This is 20 then at minimum, but it could be much greater. All right, because it's 32. It can't be that much greater. 32, this is at minimum 6 for 1 and 2 and 1 and 2. Um, hmm. Interesting. At least one of these is 6. Because it has to have a 6. They both could contain 6, which would be interesting. But at least one of them must contain a 6. Um, because we don't have other places for 6 in these columns. Right? You can only have 1 6 here for 1, 2, 3, and 6. Um, so again, these add up to 18 and 12 add up to 30, plus 24 is 54. 54, and this adds up to 32 here, minus 6. So that would be 54 plus 26 at maximum, which is 80. Which means this could be at minimum 10. But it could be up to 16, obviously. So that's fine. So if these are both 6, that's interesting. One of them could be 4. You could have 1 4 there, right? But we could have both 6s there. Does that help us any? I'm not sure. Can we ever have an 8 here? 8 would have to be with 1, 2, and 3. So the answer is no, this can never contain an 8. Because if we tried to have an 8 here, it would have to be 1, 2, 3, and 8, but these can't be 1, 2, or 8. So therefore, they would have to both be 3, which is obviously not possible. So these have to be 1 through 7 here. Does that help any? Probably not. To add up a 28 could be 4, 7, 8, 9, or 5, 6, 8, 9. So we're guaranteed an 8, 9 pair here. But the thing is, both of the 8, 9s could actually be there, technically. That could work. Um, hmm. Um, hmm. Hmm. Do we have anything here? Probably not, would be my guess. $32, which is what 18 and 14 add up to, plus 22. Obviously, these have to be 2 through 9 here. That doesn't help us much. 2 through 9 there. No 9 here because of 9 in the box. Hmm. Huh. So 22 plus 32 is 54 again. And we don't have any really restrictions here. Hmm. Um, whichever set this is adding up to 12. So if this is 1, 2, 3, 6, obviously this can't be 1, 2, 3, 6 because we have a guaranteed 3 through 6 here. So this would be the opposite one, which would be 4 and 5. Does that help us any? I'm not really sure. Um, obviously, if this is 3 or 4, it's it's different than that, so it would have to be the same as that one. But that's not a guarantee. Um, what else do we have? Mm, so this has to have a, well, it doesn't have to have a 2 here. If this is 2, then this cannot have a 2, but it could still be a wide variety of things. We do know 9 has to be either here or here in column 3. But that's not saying very much, right? Remaining digits here are 3 through 9. Remaining digits of 2 has to be one of these 3. That's all we know. We have 3 through 8 here. And then 3 through 9 here. If this one is an orange, then that means one has to be orange there, and then one would have to be orange there, which is possible. If it's green, obviously this couldn't be green here, then this would be green, and one of those 2 would be green. But that doesn't really help us much. These are again 2 through 9 here, but no 7 or 9 here because of 7 or 9 in the column. Can we have a 7 here? The answer is no. 7 must be with 1, 2, and 4 to add up to 14. So this can't be 7 there. Hmm. Let's remove the red-blue pairs. We know what they are, have to be in rows 5 and columns 5. This is obviously still odd. Oh, still odd. So no 2, 6, or 8 there. That's interesting. Okay, so can this be 6 over here? Yes, you could have 1, 6. No. If you had 1, 6 here, it has to be 3 and 4 here because 1 and 6 add up to 7. These must add up to 7. But they would eliminate all possibilities for that cell there if that's the case. So this can't be 1 and 6 either. Can it be 5 here? If we had a 5 here, it would have to be with an even number. So it'd have to be 2 and 5 here, because you have each pair of digits on a bread parity line must be odd and even. So 5 here, we're guaranteed at least 2. And 2 and 5 would have to be then 3 and 4 here. So this can't be 5 either. Interesting. So this could be both 1 and 2. And then you have like 4 and 7 or something like that. What about 6 here? Hmm. 5 and 6 works with 1 and 4 or 2 and 3. You could have 6 and 3, obviously, also. Um, huh. Okay. So at least one, obviously, at least one of green or orange has to be in one of these two cells. It could be both. That's really the question, right? Is it both? Mm. 1 and 2, 14 minus 1 and 2 would mean this adds up to 11. So that's fine. Mm. Um, so say this was a 1. That would make this 2, that 1. 2 and 1. You cannot have 3, 4, 5, 6, 7, so 2 would have to be there. 1 would be green, so that's 1. 2 would then could not be here, so 2 would have to be there. This would have to be 3, obviously. That would make this 4, which would make that 3. So no, this would have to be 5 and 6 with the 2 and 3, because no 4 anymore. So that would be 6 here, 5 there. So far that seems okay. This is not 3 and 6. This can't be 4, so that would be 5, which would make that 4 there. So this would have to be 7 with 8 or 9 there. This is 2, 1. That would force this to be 8 and 7. This is 1, 2, 4, 5, so this would have to be 2, 3, 1, 2, 3, 6. So 3 can't be here. This would be 2 and 3 as a pair. That would eliminate 3, 4 here. It's 5, 6, which eliminates 5, 6 here. 1, 2, 3, 4, 5. It's 1, 6 as a pair. That's fine. 8 eliminates 8 here, so that would be 9, which would make that 8, and then we have a problem. Interesting. So, we know this can't be green then. In the middle box. We just tried that, right? So this cannot be 1, which means it's not green, so this has to be green there. So that's 1 or 2. Right, that's actually interesting. So this is orange and green. That maybe we do want to color this orange and green then. That makes that orange and green there. The 8 here is going to be opposite of the 8 here. So then this must be green. That's orange. This is green and orange. Wait, that's not right. This is orange and then that's green. There we go. So this cannot be 3 and 4 because if it's 3 or 4, it's the orange, it's the green 3, 4, which means that would be the green 3, 4. So this must be 5 and 6, which means this is orange 3, 4 there. Interesting. Orange 3, 4 can't be here. Orange 3, 4 can't be here. So we have to have the green 3, 4. Orange 3, 4 can't be here. Orange 3, 4 has to be here. Which means orange 3, 4 has to be one of these two. This has to have the green 3, 4, but okay, so technically you could have the green 3, 4 be there. Hmm. Um, no, this is green 1, 2. It has to be with orange. It can't be with orange 3, 4, so it has to be orange 5, 6 here. So this is green 5, 6, and we have orange 5, 6. So I think this has to be a 3, 4 pair here, which means this 5, 6. So no 5, 6 here. So this is orange 3, 4 with green 3, 4. And this is orange 5, 6 here with the green 1, 2. Interesting. Um, huh. This is green. So this cannot be green 3, 4. So this is 5, 6, or 7. That's very interesting. Hmm. So this is a green-orange pair. 3, 4. That means green 3, 4 has to be one of these three. Orange 3, 4 is obviously one of those two. So this is green 1, 2, which means the green 1, 2 has to be one of those two. And technically, you could have orange 1, 2 also be there. That was interesting. Can we have 4 here? Possibly. So 4, this would be 7, 8, 9. So this would have to be 7. This would be an 8, 9 pair. This would be 3. That would be 4. This would be 1, 2, 1, 1, 2. So that would be 8, 7, 9, 8 there. No 2 or 3 here. 4 or 9, 9, no 7 or 3. No 3. We'd have to have a 1 here, so 1 would be here. 2 could not be here, so this would be 2 then. We'd have to have 3, 6, or 4, 5. This would be orange. So this would be 4, 6. This would be 3 or 5. This would have to be 2 or 4 there. 4 or 6. 5 or 7 there. 7 would eliminate 7 there, so it's 5. So this adds up to 6. 14 minus 6 is 8, so it'd have to be 2 and 6 here. That would make this 4. That would make that 9. It would be 5 there. 6 would have to be here because there's no other place for it. So far, that's looking fine. 6 would eliminate 6 here. It's 5 and 4. This would be 8, 9 as a pair. 5 eliminates 5 here, so it's 3. This would be 9. So no 9 here. It would be 8. That's 9. That would be the case anyways. No 8 or 9. 3, 4, 5, 7. One of these would be 6. It cannot be then. No, it could be 8 here. So this would have to be 9 guaranteed. That eliminates 9 in the rest of the box. No 7. No 4. No 3. We'd have to have 5 there. No 4, 5, or 9. So 3 is one of those two. This would not be 1 or 4. It's 2 and 3. No 2 and 5. It's 1 and 6. No 1, 6 here. No 1 or 9 there. No 5 there. No 6 there. No 2, 5, or 6 there. 2, 5, or 6. 1 would have to be one of those two. No 9 here, no 8 here, no 7 here. It's 2, 5 as a pair, which limits 2 and 5 in the rest of the box. Therefore, this would have to be 8. 6 and 8 is 14. 18 minus 14 would be 4, which is 3 and 1. That would leave that as 7. That would leave that as 7 there. No 1 or 7 here. No 7 there. That's working fine, unfortunately. I was hoping we'd reach a contradiction. 1 would eliminate 1 here, so that's 6 and 1, which would force that to be 3 and 2, which would force that to be 5 and 2 there. One of these two would have to be a 7, so this could not be 7 there. No 2 here. Can this ever be 8 and 9? Yes. 3 and 4 could be here. No, 3 and 4 cannot be here. So then this would have to be 6 and 9. So we have 6, 9, 3. That would force us to be 4. 15. So this would be 4 and 5. Which would force that to be 3 and 6. We'd have to have a 2 here. 2 with 7. That would be 8 and 5 there. That does add up to 22. This would have to be 7 and 8. And 2 and 3 here. No, 2 and 5 here. Okay. This would then have to be 7. That would be 8. This would be 5. That would be 2. That actually, so far this works. We have 4 and 5 there. Okay. I was hoping I'd reach a contradiction there. But that looks like the solution path. This 5-6 pair actually eliminates 5 and 6 in the rest of the box. So does the 3-4 pair, which means this can't be 4. Interesting. So this could be 1, 2, 5, 6, 8, and 9. No 9 here because of 9 in the column. Hmm. Uh, can this actually be green? If this is green, it's 2. Then 1 would have to be here, but these are opposite parities. And they're not consecutive adjacent to each other. They would both have to be adjacent to this. So this I don't think this can ever be green. If this were green, again, orange would have to be there, but that would be 1, and then 1 and 2 are opposite parity. Same with this. If this were orange, that would mean this would have to be 1 as a green. But then these would be opposite parities, and they would be adjacent to a digit, which would have to be both odd and even, which is not allowed. So this can't be orange. So this must be then the 1, 2 pair here, which eliminates 1 and 2 in the rest of the box. So orange is here, which means this can't be orange. Orange still could be here, technically, as 1, 2. What happens if we make this a 2? So we have that. It can't be 1, obviously. So if we have 2 there, that's 1, that's 2. That would be 1. We'd have 2 there, 1 there. This would be 4 and 5. That would make this 3 and 4. So this would have to be 4 here. Ah, and that's a contradiction. There you go. So this can't be orange either. We tried making this orange. It basically can only be 2 because 1 is guaranteed to be here. So then this would make this 1. This would obviously be 2. That would be 1, which would guarantee that's 4 and 5, but then 1 and 4 would have to be there. Oh, this is the orange 3 or 4 if that's the case. Okay, yeah, I guess we should have figured that out. This is the orange 3 or 4. This cannot be orange 3 or 4. So this has to be orange 1 and 2. So no orange 1 and 2 here. This becomes a 1, 2 pair here. These then add up to 3. That means so this has to be 3 through 9 here. 3 and 8. So 14 minus 3 is 11. 3 and 8 would add up to 11, but this can't be 3. So we know the orange has to be a 4. Because the orange 3, 4 is here, the orange 3, 4 is here, and it has to be one of these two. So that means we know the orange 1, 2s are 2. Okay, well, that's helpful, I guess. Oops. So then we know these are 2, which means the green 1, 2s are 1s. So this is 1, that's 1 there. That makes this a 4, which makes that a 5, which makes that 3 and 4 there. Okay. So no 2 and 5 here. It's 1, 6 as a pair. That means this can't be 1 or 4. It's 2 and 3. And everything flows from there. So we know one of these is a 4. So there's no 5 here. This has to be 4 or 6. And this is 5 or 7. 5 can't be here, so it's 7 or 9. No 5 there. No 4 here. No 5 here. This is 1. 1 has to be with 3, 4, 6 next. So this is orange there. That's green. No 4 or 6. 3 or 5. Don't know about that. So obviously one of these is even, one of these is odd. This is 2, which makes this 1. That makes that 8, which makes that 7, which makes that 9 and 8. No 9 here, no 4 here. We're guaranteed one of these is a 6. This can't be 6, though, because of the 1, 6 pair in the box. So the 6 in column 7 has to be here. So this is orange, these are green, this is orange. So we have guaranteed 6 there. No 9 here because of 9 in the column. No 7 eliminates 7 here. So this becomes 5 and 6. That makes this 4 and 5 here. No 3, 5, or 7. That makes that 9. So no 9 there. That was actually kind of clever. Anyways, 8 cannot be here because of 8 in the box. 6 can't be here because of 6 in the box. So this is a 7, 9 pair here, which means this does have to be a 4 and is the orange 4. That makes these green, which makes that orange, and therefore that has to be 8, 4, 7, 8, and 9. So that's 9, that's 7, which makes that 9. No more 9 in the row, no 1s in the row, no 6s in the row. We need a 2 here. That means this cannot be no 8 here. This is 2, 5 as a pair, no 2, 5, or 8. 9 eliminates 9 here, so this is 1, 6 as a pair. Color, there we go. This can't be 7, 8, or 9. It's 2 and 5. That eliminates 2 and 5 in the rest of the box, so this becomes... We have to have 8 here. 9 eliminates 9 here. It's 3, 7 as a pair. Again, 18 minus 14 is 4, so this must be 3 and 1. That means this can't be 1. It's 6, which makes that 1. So this is not green. This is green, which means this can't be orange. So this is green, and we have orange there. That makes that 3 and that 2. No more 3 in the box. 3 and 5, eliminate 3 and 5 here, so it's 7. Or 7 or 8 in the box. 6 can't be here because of 6 in the column. 2 eliminates 2 here, so it's 5 and 2. 3 eliminates 3 here, so it's 7. No 1, 5, or 7 here because of 5 and 7 in the column. 1 in the row. No 5, 6 here. No 2 here. No 2 and 5 here because of the 2, 5. 22 minus 7 is 15. So this must be either 6, 9, or 7, 8. We can't have 7 or 9 there. So this is an even. Let's make the oranges blue now and the greens red. So this is even, which means this must be odd, and it has to be 7 or 9. That makes this odd here, which makes this even here. So then this is 2, that's 5. No more 8 or 9 here. 2 can't be here because of 2 in the row. 6 eliminates 6 here, so that's 8 and 7, adding up to 15. So no 7 or 8 here. This becomes a 3-4 pair, which eliminates 3-4 in the rest of the column. So no 3-4, and this has to be 2 because there's no place for 2 otherwise in column 3. Since this is 2, it's even, which makes this odd. Which makes this even, which makes that odd. So this has to be 7. No more 7 in these columns, or these boxes. This is even, it's 6 or 8. This is odds, it's 3 or 5. 4 eliminates 4 here. So this has to be 3 or 9, which is odd, which makes these even, which makes this odd. So no 6 there. This must be 4. That means this is not even. This is odd. This is not odd. That's even. So even, even. This is odd, which makes this 5. 6, 4, 3. That can't be 7, so it's 5. We have a 3-5 pair in column 4, so this can't be 3 or 5. It's 9. And this has to be 6 or 8, but 4, 5, and 9 add up to 18. 24 minus 18 is 6. So we have 6 here. This is 8. 2 and 8 add up to 10. 7 and 5 add up to 12, which would give us 22. No 7 and 8 here. No 8 here. This is 3, 4 as a pair. 4 eliminates 4 here, so that's 3 and 4 there. That eliminates 3 here, so that's 6, which makes that 3. No more 4s or 6s here. 5 eliminates 5 here, so that's 9 and 5. 9 eliminates 9 here, so it's 3. 5 eliminates 5 here, so that's 3. This has to be 7, 8 as a pair. This becomes 1, 8 as a pair. 8 can't be here because of 8 in the column, so that's 1, that's 8. Not there, here. 1 eliminates 1 here, so it's 6 and 1. Remaining digits here are 4 and 6. This can't be 6 because of 6 in the column, so it's 4 and 6 there. Remaining digits in column 1 are 2 and 3. This can't be 2 because of 2 in the row, so it's 3 and 2. Remaining digits of column 2 are 6 and 9. No 6 here because of 6 in the row, so this is 9 and 6. Remaining digits of column 8 are 7 and 9. No 9 here because of 9 in the row, so it's 7, 9. 7 eliminates 7 there, so it's 8 and 7. That leaves that as a 4 and this as an 8. And that's a solution. Yeah. The logic behind this wasn't too bad. It was basically just trying to figure out what could be where, right? And trying to find contradictions, I guess. I guess I should have used the orange and green coloring a lot more. That showed up a lot here. With this being 3, 4, and this had to be the same color as this. So obviously then these, and then this 8 having to be here. That was, I guess kind of the break-in for this portion of it, was that this had to have 8, this had to have 8, so you had to have opposite coloring here for that. And that helped break apart this. So then we knew that that couldn't be the 3 or 4, so the 3 or 4 had to be there. Interesting. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.